Patterson Pope, and today I'm joined by Will Drennan with Ls3P, and we're going to talk about the Electrolux R&D facility. Give me some background on the project.
Well, the project was for Electrolux's North American headquarters, but primarily the research and development facility. So it included a lot of aspects. It was testing, it was storage, it was breakdown of other people's equipment, and it's a lot of component testing and construction as well. They built prototypes here.
Tell me a little bit about your role in the project.
My role was that of project manager and project designer. So I was the main point of contact for the client. I was involved in all the programming meetings and meeting with all these department heads that inhabited the facility to determine what their needs were going in.
What problem did Patterson Pope help you solve on this project?
Patterson Pope was instrumental in helping us determine what the storage needs were early on. We had multiple departments coming from multiple facilities across the U.S. In fact, one of the departments was formerly housed in an old hospital, and their only storage was old operating rooms, and it was just stacked. We also had multiple types of storage, be it appliance storage, stacking vacuums and refrigerators and washers and dryers, or be it stacking materials for prototyping, be it plastics or woods and metals. There were also paint issues that had to be dealt with, and along with the prototyping, we had to be mindful of code restrictions due to the flame spread certifications on a lot of these materials.
How did the project go overall?
It was a great success. We had one hiccup, and that was just a more recent code interpretation by our local code officials. But Patterson Pope came right to our aid. They sat down with us in building standards here in town so that we could figure out what we needed to do and how we needed to get there. And we were able to devise a way to use what we had purchased and still meet the code requirements just by simple modifications.
What was that issue?
That issue basically revolved around the fact that some of the materials being stored for prototyping had a high flame spread certification, and they had to be held to a certain height restriction as far as storage, so nothing over 6 feet deep in storage. And Patterson Pope helped us devise a way that we could do lower shelving and move that material around and lessen the density of what was stored. We also looked at a code interpretation that allowed us to put that material within cardboard, which burns slower than the material, giving the smoke alarm system a chance to activate before a major fire could break out.
So the shelving height was an issue because of the flammability of the product.
It was indeed.
Gotcha. So tell me, what was unique about this project?
Well, what was unique was basically the Electrolux involvement, both on the research and development piece and on the headquarters piece. You had Electrolux coming from all corners of the nation, from all types of facilities. And with that came a lot of different personalities and a lot of different requirements for the space. In the Research and Development Center, we have not only office space and meeting space for the employees, but there's storage and there are testing labs. And the testing labs vary from professional equipment, where they can actually bring end users in and show them how to maintain the equipment or how to repair the equipment, be it a washing machine that you could fit into, or be it a stove that you could cook, an 8-course meal for 800 people on. They also have labs that are dedicated to vacuum cleaner research, which is, of course, a large part of the Electrolux legacy. They prototype all their appliances there, and they test all the electronics, because the electronic component of appliances is becoming more and more prevalent. We're looking at a new age where your interaction is not through buttons and dials, but through a touch screen. And within those labs, everything's tested for durability, and that makes the project very interesting, because you get to see how these engineers think, what they're doing. You've got something that's testing how many times a cord can be pulled in and out of a vacuum, or how many times you can drop the handle, or if it can fall off the back of a truck and survive that fall. And then you have the other side where you're pumping a room full of humidity to make sure that your washing machine doesn't catch fire when it's stuffed into a linen closet.
Thank you, Will, for joining us today on this edition of Stuff Matters. We really enjoyed talking to you and learning a little bit more about the project.
Yes, ma'am.
I'm Millie Court, and that's the stuff.